Happy day. So this is starting with question 7, which is the one about Rudolph and his girlfriend Clarice. Rudolph and his girlfriend Clarice stroll east hand in hand. Actually, if they're reindeer, I suppose it would be paw and paw. That would be difficult. They stroll east hand in hand for 50 meters, and let's say that way's east. So they stroll. This is their starting position, x sub 0, and they stroll east for 50 meters to the east. And then they turn around and stroll west for 200 meters. So going west, there's 50, 100. So that's 200 meters to 200 meters west. That's meters, bad teacher. That's 50 meters over here. 50 meters east. And then 200 meters west. And the whole trip takes 360 seconds. So the total distance is just how far you physically walked. 50 and 200 is 250 meters. There's no east or west. It's just 250 meters. That's how far they physically walked. What is their overall displacement? Again, displacement is comparing where they stopped to where they started. That's all displacement means. And they started here, they ended up there. So the displacement vector is this red arrow, which is 150 meters east of where they started. West of where they started. 150 meters west of where they started. Okay? You could turn that into a math problem if you wanted to, where one of these things has to be positive and one of them has to be negative because they're opposite directions. You could make west positive and east negative. That would be negative 50 plus 200 gives you plus 150 because you made west positive. I just like to draw it. It's easier. But just comparing where they stopped to where they started. They stopped 150 meters west of where they started. If it took 360 seconds, then what's the average speed? What's the average velocity? Remember that average speed is just that distance of 250 over the time of 360. So 250 over 360. And that answer, which you already have, is 0.69 meters per second. Then the other part is what is their average velocity? And that's the one that's a v with a bar over it, delta x all over delta t. And so the delta x was 150 meters to the west, all over the total time of 360 seconds. And that came out to be whatever I said it was, 0.42 meters per second west. All right. The other part of this is questions 8 and 9. Last year's fruitcake has dropped straight down over the side of a cliff. That's a good thing to do with fruitcake, if you ask me. But if you like fruitcake, I hope you get it and enjoy it. It takes 2.5 seconds, 2.5 seconds to reach the crashing waves below. Ignore air resistance. And notice my note, which says use G of 10 as opposed to 9.8 meters per second squared. That's what I did on the exam. Remember on the exam, these are all multiple choice related questions. And all of the answers, all the correct answers are based on using 10. And I have that mentioned in bold on the test, on the final exam also. So let me erase this. Goodbye, Rudolph and Clarice. Hello, falling fruitcake. So, let me see here. So we have the purple cliffs of Dover. We have the crashing waves below. And we have the falling fruitcake. I'll put some little fruit in there. Yeah, what are we doing here? It's going to take 2.5 seconds to fall. So the fruitcake is going to fall down here. The time it's going to take is 2.5 seconds. G is negative 10 meters per second squared. And the first question was what? Calculate the approximate height of the cliff. Well, the cliff is not falling down. The fruitcake is falling down. So I'm going to calculate the displacement of the fruitcake. I'll get a negative answer. And from that, we can approximate that the magnitude of the displacement of the fruitcake is, in other words, how far it fell, is the approximate height of the cliff. The approximate height of the cliff will be a positive number because the cliff height is positive. The fruitcake fell down. We're going to equate that distance it fell to how high the cliff is. All right. We also, if we dropped it, then the initial velocity is equal to 0. And the equation I would use is the one with the t squared in it, because we know the initial velocity. We're looking for delta y. We know the time and the acceleration. So delta y, because we're in the y-axis, up and down, vertical, equals v sub 0 times t plus a half a t squared. So let's say this is going to be 0, where 0 times time is 0, plus 1/2 times negative 10 times 2.5 squared. Well, 2.5 squared, don't forget the square of the time. Hold on, I think that's 11.25. Hold on. No, gosh, I'm totally wrong. Oh, that's because 2.5 is only 6.25. So 1/2, times negative 5. God, what's wrong with me? Did I get that answer right on the worksheet? Yeah, okay, sorry. Yeah, I got it right. So a half of negative 10 times 2.5 squared is negative 31.25 meters. That's the displacement of the fruitcake. Therefore, thus, hence, if that's the displacement of the fruitcake, then it must have fallen from a height of 31.25 meters. That's the height of the cliff. Okay. What's next? With what velocity does the incredibly dense, I'm sorry, I laugh at my own jokes, it's just pathetic, and not so yummy fruitcake strike the rocks below? That one, there's a bunch of ways to do this. I'm going to use, I think, the easiest equation of them all, which is this one. Again, that's going to just be negative 10. It makes the math so much easier. So that's why I use that on the multiple choice, because you don't need to have a calculator. Obviously, I did over there, though. That you can use negative 10. What is that? Times 2.5 plus 0, because it starts from rest. So that's negative 25 meters per second. All right? Okay.